Hello! So if you remember in the last video, we were talking about this whole idea behind a simple random walk. So in other words, we start at a central position. We start at, say, a position t equals 0, and we can either move left or right from that position. Okay, and after each time increment, so in other words, we're incrementing the time by 1 second each time. So after each second, we either move to the left or we move to the right. Okay, and we end up at a different position each time, and that's what we're doing in the last video. Okay, and we try to map out, how we were moving, and that's basically what this is doing. That's basically what this diagram is doing down here. Okay, and we can also map the probabilities. We can also map the probabilities that we're going to end up at a particular point in time. Okay, and we did all that in the last video. So, I mean, if you didn't watch the last video, go back and watch it, because otherwise this video isn't really going to make a lot of sense. So now what we want to try and do, okay, because this is effectively a model, okay, it's a model, it's a one-dimensional random walk model. A dimension is just basically, a movement, if you like. A dimension is just basically a movement, so a dimension, if you like, is just a line. So, that is, you can either move left or right, okay, in this particular example. So we can either move left or right, and that's it. We can't move up or down or forwards and backwards. We can only move in one direction, left and right, okay? But we didn't really sort of define any of the mathematics involved. So what we want to try and do now in this video is come up with a bit of the mathematics. Okay, so I kind of left you off at the end of the last video, kind of hinting towards that this could represent a binomial distribution, but I didn't really look into it in that much detail. So what I now want to do in this video is introduce a bit more of the mathematics and kind of, justify a little bit more the distribution. Okay. Because what I want to do is basically say, well, okay, what is after so many seconds, what is the probability that I will end up at such and such a point? So, for example, after t equals 4 seconds, what is the probability that I will end up at position 4? Okay, so let me just define a few variables. So let's say that m is my position. Okay, so is the position that I end up with. So say, for example, 4, that would be my m. Yeah, so 4 would be my position. It's just where I end up. Or -5, that would be my m. So it's just the position on this line that I end up at, just where I end up at along this line. Okay, and let's say that n is the number of steps that I've taken to get to that point. So the number of steps that I've taken in total in order to get to that point. So, for example, let's take for example position 3. Yeah, let's take for example position 3. M would be 3, so m would be 3, and the number of steps that I've taken to get to that point. So let's say that the number of steps that I've taken to get to that point is 3 steps. Okay. Well, therefore, I know that I've gone from there to there to there to there. So I know that I've gone from, or let me just write it out down here. I've gone from 0 to 1 to 2 to 3. Yeah, so that's sort of the number of steps I've taken to get to that position there, because I always start at the origin. Okay, whereas, for example, if I was taking my position to be 1, so m equals 1, okay, and I know that the number of steps that I've taken is 3, then therefore I know that I can't have got to 3 after 1 second, for example. Can't have got to 1 after 1 second, because I had to have taken 3 seconds. I have to have taken 3 steps. Yeah, and after 1 second, I can only have taken 1 step. So although after 1 second I could be at position 1, okay, because I haven't taken 3 seconds after 1 second, okay, therefore I know that, it'll have to be after time equals 3 seconds. In other words, I must have gone from, let's say, for example, I could have gone from here to here and then back to 1 again. That is a possible route. There are other possible routes as well. I could have gone from 0 to -1 to 0 to 1. Yeah, there's lots of different routes that I can take. But yeah, basically, I'm defining just m as my position and n is my number of steps. And actually what I'm going to do is I'm going to just narrow it down a little bit. And I'm going to say m is actually, or rather I'm going to define now a probability based on these two things. A probability of m and n. I'm going to define this as the probability. That, our walker, because if you imagine this is a man, I'm walking 1 step each second. This man, or I'm at a position, or I've reached a point, m steps to the right after n time steps. Now, why do I take m to be right? So why do I take m to be the right? Well, basically, the reason why, I mean, I could equally be left. I'm just taking it either in the right direction or either in the left direction. And the reason, the reason why behind that is because the probability of me moving right is a half, okay? Which is exactly the same as the probability of moving me left. Yeah, I've got an equal chance of either moving right or left after each time interval. So basically, I just take right for convenience, but equally it could be left because that's exactly the same thing, because the probability of moving right is exactly the same as the probability of me moving left. So I'm just for convenience going to consider right. Just say right. I'm going to move to the right. So, P of mn is just the probability that I've reached a point which is m steps to the right, after n time steps. Okay. So let me just try and define sort of things a little bit more detail. So this is basically what I'm trying to define a little bit more detail. Okay, so basically, that thing which I was just saying, because probability is equal, probability of moving to the right is exactly the same as probability of moving to the left. So in other words, probability of minus m and n is exactly the same as probability of m and n. Because, m is position to the right and minus m is a position to the left. So, for example, what is the probability that I'm at position 3? Well, that's exactly the same as the probability that I am at position of negative 3. It's a bit like, if I just drew a line down, the centre, that would be perfectly symmetric. Okay, that would be perfectly symmetric, and you can see that via the probabilities. If I draw a line down there, you can see that the probabilities are perfectly symmetric each side of that line. Okay, so yeah, because of the symmetric nature of this random walk, then I can just kind of consider that those two things are the same. Okay, so let me define these things in a little bit more detail now. I'm going to basically say, well, delta is the distance which I move in a single step. So delta is the distance moved in a single step. And I'm also going to define tau. As the time taken for a single step. So tau is the time taken for a single step. So therefore I can now say, well, okay, I'm going to let x be my position after moving position m. Well, how far have I moved? I've moved by delta. Okay, so I've moved, m is, if you like, the position which I end up at. So the number of steps which I've taken to the right to end up at that position x. Okay, so delta is just the total distance which I've travelled. It's a bit like saying, okay, I'm at position 3. Okay, and say if each one of these things is a metre, then therefore I've moved 3. So I'm at position 3 times 1 metre. So therefore I'm at position 3. Okay, so I've taken 3 steps, each of 1 metre. So therefore I am at position 3. Okay, and likewise I'm just going to define t as time. So time is just going to be my times taken for a single step times by the number of steps which I've taken, which is n. Okay, so say for example, I've taken 3 steps. So this is exactly the same as what I was saying before. Say if m is equal to 3, or rather if I do this at m, so I've taken, at position 1, and I've taken 3 steps. So this is exactly the same thing as I was saying up there. Okay, so basically, it's just kind of defining things in a little bit more detail. Okay? In other words, I'm just defining things in terms of distance and in terms of sort of distance for a single step and distance in terms of and time in terms of a single step. So I'm defining things in distance for a single step and time for a single step. Okay? Okay, so let's again just go back to our example. Let's suppose that I'm at position 1. And in order to get to position 1, position 1, so in other words, x equals 1 now. So I'm at position 1. And in order to get to position 1, we've moved, let's say we've moved 1 step to the right. So that's not going to work. Let's suppose I've moved 1 step to the left and 2 steps to the right. So 1 step to the left and 2 steps to the right. So I've gone left, and then right again. So in other words, I've gone 1 step to the left and 2 steps to the right. Okay. So therefore, I can define now my m, which is just my position. So I'm at position 1. Okay. I'm at position 1. My position 1 is just going to be the number of steps taken to the. So maybe if I just write that down. So let's say the number of steps to the. Let's say that let's say that the number of steps taken to the right is going to be A. Okay, so the number of steps to the right is going to be A, and let's say that B is the number of steps to the left. So I've got these two things defined now. Which now means I can determine my position in terms of the number of steps taken to the left and number of steps taken to the right. So it's just going to be number of steps taken to the right minus the number of steps taken to the left. So say, for example, if I was at position 1, okay, and I've moved one step to the left, so from 0 I've moved to -1, then I've moved back to 0, and then back to 1 again. So where have I ended up? Well, I've taken 2 steps to the right, okay, and I've moved 1 step to the left, so therefore I'm at position 1. Okay, likewise I could do exactly the same for position -2, let's say. Let's say I've taken 1 step to the right and 3 steps to the left. So 1 step to the right and 3 steps to the left. So 3 steps to the left. So therefore, I must be at position -2. Okay, so basically, I can now determine my position in terms of the number of steps which I've taken to the left and the number of steps which I've taken to the right. Okay, and I can also determine the number of steps which I've taken as just being the number of steps to the right plus the number of steps to the left. So in other words, if I've taken 3 steps in total, okay, 1 of them has been to the left, and then 2 of them have been to the right, then therefore the number of steps I've taken in total would be 4. Did I say that right? 1 step to the left, 2 steps. I didn't say that right, did I? I'm not sure. I'm not sure what I said. Anyway, if I take 1 step to the left, okay, and 2 steps to the right, then the number of steps that I've taken in total will be 1 to the left, 2 to the right. Number of steps taken in total will be 1 plus 2, which is 3 steps. So I've taken 3 steps in total. Okay, so I can now determine this. So really, this is just kind of I don't know how necessary it is. Basically, if you're a little bit confused by this thing, as I initially was when I kind of met it, I thought, well, why are we needing that? Basically, all this is doing is just saying, okay, if we now have to introduce distance, or if we now have to introduce, distance for a single step or time taken for a single step, then we can do that, absolutely. But since we're just assuming that each distance is constant and each time is constant between each step between each step, of course, if they're both constant, then we just consider m and n on their own. Okay, just m and n on their own. But if the time taken between each step isn't constant, and if the distance taken in between each step, if that's not constant, then we have to introduce this thing. Okay, but for the moment, we don't really have to worry about it too much. Okay, so that's defining everything. Yeah, so maybe if I just say that in a little bit more detail, well, okay, because we're just assuming that the delta and tau are constant. So in other words, we can just take those to be 1. We can just take both those things to be 1. So, for example, the time in between each step is just going to be 1 second, and the distance in between each step is, I don't know, just 1 meter or something like that. Okay, so therefore these two things are constant. So therefore I can say that x is just going to be equal to m. Because I've just taken these two things as 1. So therefore I can just say that x equals m and t equals n. So basically they're just the same thing in this example. But if I have to now introduce different distances or different times in between each step, then I can easily do that. So okay, now what I want to do is I just want to rearrange these two things. So I want to rearrange this, or I can solve it simultaneously rather, to find out what a and b are equal to in terms of m and n. So let's try and solve these two things. So let's say, well, okay, from this a is equal to m plus b. Okay, so therefore if I sub that back into n, I end up with n equals m plus b. Plus b, so that's m plus 2b, right? So therefore b is equal to n minus m over 2. So that's what b is now equal to. So if I just write that around the other way, so b is equal to n minus m over 2. B is equal to n minus m over 2. Okay, and a, yeah, I now know that a is equal to m plus b. Well, I know that b is equal to n minus m over 2. So n minus m over 2, okay? So therefore, if I just do a little bit of sort of algebraic fraction work, so this, if I just multiply this by 2 over 2, then therefore this becomes over the same thing. So I just write this over the same thing. So therefore I end up with 2m minus m, so I just end up with 1m, so m plus n over 2. n plus m over 2. So in other words, these are now my two things which I'm after. So I've got a and b written in terms of the number of steps taken, which is n, and I've got it written in terms of the number of my position as well. Notice as well that I can just write b quite happily as n minus a. That's another way of writing it. So just rearranging that as well. It doesn't really matter too much, but basically, I can rewrite those two things anyway. So the number of different ways now that the walker can reach some particular point. So let's say, for example, some particular point, and I'm just going to, for convenience, define it as x, because obviously, I've taken the time and effort to introduce delta and introduce tau as just the time and distance taken in between each step. So it kind of now makes sense just to use that notation. So let's say, for example, I want to reach the point 2 or 3, so just some point x. So let's say, the number of different ways now for me to reach some particular point x will be given by, let's have a look. The number of ways to reach, it'll be just to be given by the number of different ways to reach a particular point under binomial characteristics, because notice that with this, I can either move left or right. There's two choices which I can take, which means that I've got a binomial thing going on. If I've only got two options for something, then therefore it must be a binomial kind of distribution or binomial characteristic at the very least. Okay, so it's a binomial characteristic. Well, I know that the number of ways that I can do something, so the number of ways that I can choose, so the number of steps, so I can choose, the number of steps that I can choose, the number of steps to the right that I can choose from the total number of steps that I take. So remember, I'm just considering a position which is on the right. Okay? So the number of steps which I take to the right is given by A. Okay, and the number of steps I take in total is given by n. So in other words, if I want to be at a particular position, position which is on the right automatically, then it's just going to be the total number of steps that I can take, the total number of steps that I can take, and I'm just choosing the number of steps that I take to the right from that. So in other words, it's going to be, the number of steps I can take in total, and I'm going to choose the number of steps that I can take from the right from that. And there is a formula for this. It's basically, n factorial over a factorial times n minus a factorial. Okay, so there is a formula for that. So basically, now what I can say is I can find the number of different ways. That a walker can reach a given point. The number of different ways that a walker can reach a given point. So the number of ways that, I can reach this point will be given by this. So let's say, for example, I want to find the number of ways that I can reach position 3. Well, therefore, it'll be given by the total number of steps that I've taken, and I'm going to choose the number of steps that I taken to the right. Okay, so it's going to be given by this thing. Okay. I can also talk about the total number of paths as well. So the total number of possible n-step paths, so just an n-step path. So say, for example, after, a 3-step path is a path which I can just move 3 steps. So 3 steps I can, let me just draw this out. So I start here, I start in the middle. Okay, a 3-step path, I can go either that one, and then that one, okay? Or I can either go right, then left, and I can do the reverse of that as well, okay? Or I can go right, then left, or, you get the idea, basically. 3-step paths is either just moving the number of different paths that I can have, consisting of 3 steps, okay? And it's obviously going to be 2 to the power of n. So, say if n was 3, that's the number of steps I've taken, 3 steps, then, the total number of steps, the total number of paths I can possibly take is 2 to the n. And hopefully you might be able to see that, actually, from this kind of tree, because there are always 2 possibilities that I can move. So in other words, I start here, okay, and I can either move left or I can move right. Okay. And then likewise here, I can either move left or right, but then I have to multiply it by the number of ways that I could already move before. Okay, or I can get to that point, rather. Okay, and then likewise, if I end up at this point, it's that way. So there's always 2 possibilities. There's always two possibilities, left or right. So this is now total number of paths that I can have. Total number of paths. So this is just the total number of paths that I can have to get to a particular point. So say, for example, it's the total number of paths that I can have to get to this point. okay, given, you know, that I've taken 5 steps or 3 steps or whatever. Okay, so given I've taken n steps, the number of paths that I can take is given by that. So say, for example, if I've taken 5 steps, the number of paths that I can take is 2 to the power 5. Okay, so obviously, you know, it's increasing all the time because I'm increasing the number of ways that I can, you know, the number of places that I can end up at. Okay, and so the required probability that I want. So remember what I want. I want the probability of me reaching a certain position, given that I've, you know, and based on, you know, the position which I want the probability. Let me try and say this again. I basically want to come up with the probability of me reaching a certain point in time, okay, based on the fact that I'm at this position and that I've taken this many steps. So I want to find out the probability that I will end up at a particular point, okay? So the probability that I will end up at a particular point, okay, will be given by this. Well, it's just basically the number. It's going to be the number of n-step paths, okay, that end at that finish at or that go to my position. Okay, so this is just the number of paths. So say, for example, 3 steps or 5 steps or whatever that I can take, you know, the number of paths that I can take which get me to a certain point, you know, on this number line. Okay, it's the number of paths that it's the number of steps which I can take in my path to get me to a particular point on that plane, divided by the total number of n-step paths that I can take in total. Of n-step paths that I can take in total. Okay, and that kind of makes sense. Okay, because, you know, it's going to be, I want to find the probability that I will end up at a particular position, and that after I've taken so many steps. Well, that's just going to be the total number of those paths that I can take. You know, total number of those 3 steps or 5 steps or whatever paths that I can take that go to that position, divided by the total number which I can take if possible. So it's divided by the total number of different paths that I can take. So say, for example, you know, let's consider a small example. I start here, okay, and my position is at say 2, so that's 1, that's -1, that's -2. So, and I've taken 3 steps. Okay. Well, the total number of paths that I can take of 3 steps, I can either go here and here. Anyway, you can kind of get the position. So the total number of paths that I can take is 2 to the power 3, which of course is 8. Okay, and you can verify that. Actually, maybe if I just take a 2-step path, just kind of simplify it. So in other words, I can only take 4 steps. So I can go either here and here. Okay, and then here, and then here, and then here. Oops. Okay, so these are all the different positions I can end up at. I can end up at -2, I can end up at 0, or I can end up at 2. Okay, we did all this before. In here. You know, this is essentially what we're doing in here. So now, you know, the total number of paths that I can take, or the total number of n-step paths that I can take is 4. Okay, but only one of them will get me to 2. Only 2 of them will get me to 0, and only one of them will get me to -2. So in other words, you know, the probability that I will end up at position -2, let's say, is going to be the total number, so the number of n-step paths that go to m. So there's only one of those. Out of the total number of n-step paths in total. Well, there's 4 different paths that I can take, so it's going to be 1 out of 4. Okay. Likewise, it's going to be exactly the same for 2 as well. So this is the probability of -2. Given that I've taken 2 steps, and it's exactly the same as the probability of 2, given 2. Okay, so let's say, for example, the probability of me reaching 0 after 2 steps, well, that's going to be, there's 2 different ways of getting there. I can either go down this route and then this route, or this route and then this route. So there's 2 steps that I can take, and there's 4 different paths that I can take in total, so therefore the probabilities are half. Okay, and you can go through and you can work through that kind of idea, and you can verify that they do actually, oops, that's the wrong one, this one. You can verify that they do actually make sense, that they do actually coincide with the probabilities in here. Okay, so in other words, now if I just want to write them out sort of more formally, so in other words, it's going to be 1 over 2n, so that's going to be the probability, it's going to be 1 over 2n, So probability of m given n is going to be 1 out, it's 1 over the total number of paths that I can take, 2 to the power of n, okay, times by the number of ways that I can get to that particular point. So a factorial times n minus a factorial, okay? And so then this basically will define, it's just basically a binomial probability. Okay, it's the number of ways out of the number of objects, okay, which is essentially what's going on there, times by the number of different ways that I can get that object. Okay, so that's essentially just what is going on there. It's essentially what's going on there. So it's just a binomial. It's just binomial distribution, a binomial characteristic.